Hey everybody, this is Miss Eisencraft with Unit 1, Lesson 6, Practice Problems for Geometry. So let's get going. All right. Which of the following constructions would help to construct a line passing through point C that would be perpendicular to AB? Okay. Would a construction of an equilateral triangle with one side AB? No. How about construction of a hexagon with one side BC? No. This one confused me at first. Construction of a perpendicular bisector through C. So if we made a perpendicular bisector, not to AB, but we would need to, draw a circle using C and then have 2 points equidistant from C and then draw a perpendicular bisector through C. Then that would create a perpendicular line through C that goes through line AB. It's a little bit weird because they're labeling the line with 2 points instead of like line L. So you're assuming they mean, or I was assuming they meant, bisect AB. No, that's, but it would just bisect this line. Yes, that construction would be helpful. And how about construction of a square with one side AB? No. Okay, next one. Two distinct lines, L and M, I'm going to just sketch these, are each perpendicular to the same line N. So if L and M are perpendicular to line N, so let me draw M, okay? Right? L and M are each perpendicular to this line. So L would look like this, and M could possibly look like this. So are L and M perpendicular to one another? No. Are L and N perpendicular to each other? Yes. Are M and N perpendicular? Yes. Are L and M parallel? Yes. Are L and N parallel? No. And are M and N parallel? No. Oh, boy, sorry about that. Okay, next one. The diagram is a straight edge and compass construction of the bisector of angle BAC. If only angle BAC is given, explain the steps of the construction in order. So if only BAC is given, try not to make this too long. Okay. What did we do? Well, we first took our compass and we marked the two rays, 2 spots equidistant from the vertex. So let's say create a circle centered at A. And it's going to pass through B. That passes through B. It doesn't have to, but it does over here. Okay. All right. So this makes a point D on segment AC or on ray AC. This makes point D on ray or segment on the ray AC. Okay, so right there. All right, so we got those 2 points. Then we basically made 2 congruent circles, one centered at B, one centered at D. And how you could say they used radius BD, or they was centered at B, passed through D, and the other one was centered at D, passed through B. So how should we say that? Maybe quickly. I think the book does a good job. It says, next, draw a circle with center B. Draw a circle centered at B, containing D. So using that radius. And then draw a circle centered at D, containing B. So they basically have that radius of BD for both of them. Those 2 circles meet at 2 points, we'll call them EF. So let's say these two circles, ones you just drew, meet at 2 points. Okay, we're going to call them E and F. Draw a line through points E, F, and A. The vertex. I'll go alphabetical. Draw line. Draw a line through points A, E, and F. All right, lots of different ways you could say that. We're just practicing, trying to be as clear as we can, giving our steps to the construction. All right, number 3. Nope, just kidding, number 4. All right, here's another diagram, looks familiar. Okay, it's a line perpendicular to AB passing through point C. So it is a perpendicular bisector. All right, which segment has the same length as EA? Well, it looks to me that EA is a radius of this circle. Okay, they both big circles share a common radius, so every radius over here on circle D, centered at circle D, would be equivalent to all the radii over here. So EC, no, that is not a radius. It doesn't go from the center of one of these circles out. Okay, how about ED? Yes, it is the radii of this circle, which shares a common radius with this circle. How about BE? No. And BD? No. I was only looking for one. Okay, this diagram is a straight edge and compass construction. Which triangle is equilateral? How do you know? Okay, we're looking like we have a bunch of equivalent circles, same circle sharing a common radius. And it looks like the sides of these are the length of 2 radii. 1, 2, 1, 2, 1, 2. So triangle VWZ has 3 equal sides. Each have length of 2 radii. Where this one, it looks like the TS and TU are both a radii, but SU is not. It is different. So nope, not equilateral. Isosceles though. What? Okay. In the construction for number 6, A is the center of one circle and B is the center of the other. Name the segments in the diagram that have the same length as segment AB. So any radii at all. This looks like the rhombus problems in lesson 5. So any radii of circle A or circle B will be the same as AB, because that's the shared radius that created the circles in the first place. So we have AC, AD, BC, and BB. All of those segments are the same as AB. They're all radii of circles with a common radius. Okay. Number 7. This diagram is a straight edge and compass construction. A is the center of one circle and B is the center of the other. Name a pair of perpendicular line segments. Okay, so CD and AB. Okay, we create that 90-degree angle. This is the construction we did in class. Okay. Name a pair of line segments with the same length. So I'm going to go with the fact that this is a perpendicular bisector, right? These point C is equidistant from A and B. Point D is equidistant from A and B. So this line is the perpendicular bisector. It contains all points equidistant from A and B. So M here is equidistant and it's on the segment AB. So it is the exact midpoint. So that would mean that AM is the same as MB. Last one. A, B, and C are centers of the three circles. Select all segments that are congruent to A, B. Once again, we are looking for radii of the circles because AB is the common radius. All right, so we're going to look carefully. There's a lot on here. HF, that's 2 radii, too big. HA, okay, so if you look at this bottom left circle, HA or AH is a radii to this bottom left circle, which is the same, which matches AB. How about CE? It goes from the center, but not to this edge of the circle. CD goes past. Yeah. BD, center, edge of the circle. BF, circle centered at B. Yes, it is a radii of the circle centered at B. All right. Hope that helped. Happy constructing.